All right, so to get started, we're going to talk about the cyclic heart process data available with these AXL HART modules. First off, we're going to get into the AXL control, or any AXL F heart module connected to an AXL control local bus. So for an example, this would be the AXL control F2152 standard PLC. All right, so here we have PLC Next Engineer, and we're going to show how to get the heart cyclic data exchange, the cyclic process data, into the PLC. So in order to do so, you're just going to connect PLC Next Engineer up to your PLC, and since we're talking local AXL F I/O, we're going to just simply read our local bus here. Doing so is going to discover everything that's connected to the local bus. Here we've got smart elements and what you see here, AXL F AI8 heart. So in this AI8 heart, we can configure this. We'll see this look in a similar fashion for the other cyclic data exchange examples. But yeah, you can configure channels 1 through 8 to enable or disable the 420 milliamp signal. And then on the heart side, you can enable or disable each individual channel, with or without alarms, depending on what you would like. So in our scenario, I only have one physical heart sensor connected to channel 1, so I'm going to just disable all of the other channels because I'm not using them here. Again, I've got one heart sensor connected to channel 1, physical terminal channel 1. Under process data, we can actually map different heart data into different slots, as we're calling them. So for example, heart channel 1, it's a physical channel 1, and I'm going to pull the PV. So I want to read the primary variable from heart channel, or from channel 1 in the module. So in my second heart slot, my second process data item, I can now pull from channel 2, but like we just discussed, channel 2 is empty, is disabled. So I have a heart device on channel 1 and I want to pull not just PV, but I want to pull SV. Same thing, I want to pull the TV and the QV. So I'm going to simply set the first 4 channels, or the first 4 slots, to all pull from channel 1, but I pull PV, SV, TV, and QV. Lastly, I'm also going to pull loop current. So PV, SV, TV, QV, and loop current. Now doing so is going to configure the analog input module to only pull on channel 1, like we showed here, only pull on the enabled channel 1, and to put this process data into these locations, into these slots. So we're going to open up a project where this has already been done and look at some variables. All right, so now we have a project that is running, same exact configuration that I just showed you, where we have channel 1 enabled for the 420 milliamp, as well as channel 1 enabled for heart, everything else disabled. And our process data here is pulling primary variable, secondary variable, TV, QV, loop current, all from channel 1. So if I go to the data list, I've created variables in the PLC to map and pull in this information. We can see here there's our 420 milliamp signal and our heart process values. So we see here PV, SV, TV, QV, loop current, and these are the values here. So these are pulling live process values, live heart data in a cyclic fashion from the module. And that's pretty much it. That's how we get your cyclic process data, your heart cyclic process data from a analog input, or a heart I/O module that is on the local bus of a PLC, like the 2152. All right, so now that we've discussed how to get the PV, SV, TV, QV, loop current, cyclic heart process data when the heart module is connected to a controller, we're going to go next to a bus coupler. So AXL F local bus. So we're looking for a heart module, an AXL F heart I/O module that's connected to a bus coupler instead of a controller. Now this is slightly different, but it's going to look very similar depending on the protocol you're using. If we're doing Profinet, it's going to look very similar to what we were just looking at on the controller side. If we're doing Modbus TCP, it's going to look pretty different. For this example, I'm just going to show Profinet, but the configuration and the available options in the Cyclic HART process data is the same, whether you use Profinet, Modbus TCP, Ethernet IP. When you're getting your Cyclic HART process data, you can have PV, SV, TV, QV, and loop current. So let's go over to PLC Next Engineer and we'll take a look. All right, so now that we're back in PLC Next Engineer, we're going to show how to get the HART process data from a HART module that's behind a bus coupler. In this scenario, we're using a Profinet bus coupler, and so I've already dragged it from the catalog into the Profinet structure. We're simply going to connect to the PLC and read that Profinet bus coupler local modules. We see here one of our HART I/O modules is available. Just like before, we're going to be able to configure this I/O module. So we're going to, again, enable only what we have available. I have a HART sensor connected to channel 1, so I'm going to enable channel 1 and disable everything else. You'll see this is the exact same setup, same configuration as when the module is next to the controller, next to the local bus of the PLC. Same as before, we're going to go ahead and configure the slots, the process values, the process data to pull from channel 1, because that's where our device is. And we're going to pull PV, SV, TV, QV, and loop. PV, SV, TV, QV, and loop current. All right, so lastly, we'll grab loop current. Very good. All right, so I'm going to go jump back to the program that I've already created with this exact same configuration. All right, here we are back in PLC Next Engineer, and we can see that the analog input module, the HART module, is connected to a Profinet bus coupler. So if we open up the configuration settings, this is what we just configured, where we've got one channel enabled, and we're only, again, on the HART, only one channel enabled, and everything else is disabled. On the process data, we're looking for PV, SV, TV, QV, loop current, all pulling from channel 1. So if we go to data list, we have our global variables that we've created here. Again, our 4 to 20 milliamp, our PV, SV, TV, QV, and loop current. We can see these are all the cyclic HART process values coming from the HART sensor. So that's pretty much it. This is how it's done in Profinet for a Profinet bus coupler. For Modbus TCP, Ethernet IP, Profibus, it's a similar setup. It depends really if you're using a device description file like in Profibus and Profinet, or in Modbus TCP if you're just pulling registers. Again, you're just going to get your process data however you normally would in that protocol. So let's go back and look at the third HART module for Axial Line P. All right, so last Axial Line module that we have with HART, we're going to look at the Axial Line P bus couplers and how to get the HART process data, PV, SV, TV, QV, and loop current into your controller when you're using Axial Line P. All right, so here we are back in PLC Next Engineer, and what we're going to do now is look at the HART cyclic process data using Axial Line P. So right now, the only way to get Axial Line P into PLC Next Engineer is to import the GSDML file. So we're going to grab the GSDML file and open it and import it into PLC Next Engineer. This is going to show up here under Network, under Local Devices. Once available, we're simply going to drag it over and configure the bus coupler in the way that we normally would any Profinet bus coupler. All right, so once that's configured, we're simply going to, as before, read the Profinet modules to decide or to discover which I/O modules are connected on the local bus. All right, we see 4 modules here, so we're going to grab our heart one, and same as before, we're going to only configure what we need. So we have one sensor connected to channel 1, so we're going to have everything else disabled. Under heart channels, again, we're going to enable only channel 1 and have everything else disabled. Under the heart process data, again, we're going to pull PV, SV, TV, and QV. And so to do that, we're going to point slots 1, 2, 3, 4, and 5 to PV, SV, TV, and QV coming from channel 1. So the thing to note here is that the configuration for the AXL line P will be the exact same as the AXL line F from a Profinet standpoint once the GSDML has been loaded into PL/SYNCS Engineer. This is expected early 2022. So for now, you have to import the GSDML manually, and the configuration for the process data is slightly different. Under data list here, for the analog input module, instead of the broken out processed elements, process data elements for each channel, everything is contained in a 48-byte packet, a 48-byte array. And so that looks like an octet string of 48. In order to get the information from that 48 bytes, we're going to have to write a very, very short program. So first things first, we're going to add a data type. And in here, we're going to create the data type for the octet string. So simply just making any old data type here. We'll call this octet string 48. And we're going to say it's an array of 48 bytes. So now that we have a data type that matches the 48 byte array, we can go ahead and create a variable and map that variable to this value right here. So if I go to PLC, I can simply create a variable, AXL line P, AI8, heart. And we're going to call this variable a octet string. All right, so now that we have that octet string, we can simply map that to the input byte array, 48 bytes, and we're off. Now, once the actual process values have been mapped, again, it comes in 48 bytes, so it would be good to break apart these 48 bytes. I'm going to show you how I've done that in the next step in the next program. All right, so now again, back in PL/SYNCS Engineer, I've already got a program created here. So I'm going to show how I've configured the analog input module, the heart module for AXL line P behind the AXL line P Profinet bus coupler, the same way that we just showed in the previous configuration, the previous project. We see here only channel 1 is enabled, and we have slots 1 through 5 looking for PV, SV, TV, QV, and loop current. So if I go to the actual data list here, again, we're only going to see this heart, this input 48 bytes, give us the entire 420 milliamp and heart data. So what we've done here is that 48 bytes is broken out into the analog input data in bytes 0 through 15. So the first 16 bytes are the analog input data, and the next 32 bytes are the heart data. What I've done here, just to make it kind of clear, is I've created a variable, I've created a word, and I've mapped just byte 0 and byte 1 into array indices 0 and 1 of the actual 48 byte array. So what this does is this puts the first 2 bytes of the array, and it puts, like I see here, 2 bytes per channel. It puts them into channel 1. And I do the same thing for channel 2, channel 3, channel 4. I only have one sensor connected, so everything else is commented out. If I go down here to the heart stuff, we see here the process data type, again, is heart input, PV, SV, TV, QV, loop current, and it's bytes 16 through 47, or the next 32 bytes. We have 4 bytes per channel, so in a similar fashion here for channel 1, I made it a double word, and chose the actual word and the bytes and actually populated, indices 16, 17, 18, and 19. And all of these four indices, all of these 4 bytes in the array make up the process data item for channel 1, the HART slot 1, or the HART process data for slot 1. So what I did is I just converted this double word into a real, and then this is the process variable that has the actual PV. So this would have the actual process variable for HART, and I can show this if we just go online. We can see here, let's go back up to the 420 milliamp. So the 420 milliamp, again, we see here 18D7 is the 2-byte process data element for analog input. We see that here being broken out and put into this word. And then down in here, again, first 4 bytes, where we take, byte 0 and byte 1, byte 0 and byte 1 from word 1 and word 0. Put it all together, and that gets us a real value here of the PV. So we've got PV, SV, TV, QV, and then down here, loop current. This is a pretty convoluted way to pull in all of the process data for an I/O module. The reason it's pretty complicated and convoluted, in my opinion, is because we don't yet have the GSDML loaded into PLC Next Engineer. Once this is loaded into PLC Next Engineer, we can utilize some features of FDCML that allow us to break apart this 48 bytes into 8 2-byte words and then 8 4-byte reals or floating points, just like the other AXL F I/O modules for this HART process data. When you import a GSDML, it should always look like this, where it just pulls the octet string information. PLC Next Engineer does not handle this clearly, and so this is why it looks like this. But rest assured, once the newer versions of PLC Next Engineer are released, this setup and the configuration will look very similar to AXL F. For now, this is the setup. Create a data type of octet string, 48 bytes, and go ahead and map it to the input array. And then you can go into that array and step through and pull each individual indice out, load it into the proper location, and then you have a process data element or a process variable in the same format that you have for the other I/O. So that's pretty much it. That's how you get your process data from your HART module on AXL P into your controller. If you do this in other controller softwares like Siemens or ABB, the process is much more simple, and there's none of this programming here to pull the array apart. But it is what it is for now. And yeah, that's pretty much it. That's how you get the Cyclic PV, SV, TV, QV from all of our AXL HART modules, whether it's through the local bus for PLC Next Engineer, or the local bus for the AXL control, through a AXL F bus coupler like Profinet, or an AXL P bus coupler like Profinet.